As Gregory said, I'll tell about past, present, and future challenges which we meet on our way to the carbon age. Based on reports, questions, discussions, and voting results, I can state for sure that everybody here does understand that single-wall carbon nanotubes, or as we often call them, graphene tubes, is a unique material characterized by a number of exceptional properties, and due to these properties, 70% of the materials all over the world can be improved. But you know that carbon nanotubes was discovered more than 25 years ago, maybe 40 years ago, and nevertheless, we just recently, 4 years ago, 5 years ago, we have not seen materials produced on the industrial scale improved with single-wall carbon nanotubes. Why? The answer is very simple. There was no scalable technology of production of high-quality single-wall carbon nanotubes. It was challenge number one. 4 years ago, we solved this problem. The production facility called Graphitron 1.0 was launched. By the way, index 1.0 indicated that the reactor would produce 1 ton per annum. Right now, the capacity exceeds 10 tons. It is the result of our R&D work on development of the technology of synthesis. And it means that now we produce more than 90% of the single-wall carbon nanotubes in the world. Okay, so the first challenge was solved, but these are the main parameters of our product, which is produced under the trademark Tubol. This is what is OCSiAl today. We have more than 350 employees in 14 countries. We work with 1,500 partners in 40 countries. The next step in our efforts on development of the technology of synthesis will be Graphitron 50. This reactor will be launched next year on the industrial scale. The first samples are going to produce just in the coming weeks. So the first challenge was solved, and what about the market? There was no market for this new product, and from the very beginning of our project, we have been working on forming the market through developing applications of Tubol. To do that, we built a team of scientists. We created several laboratories. We created prototyping center where we can produce industrial technologies and products. What is our basic approach to developing Tubol-based products? We do understand that our potential customers do not want and will not change the technological processes of the production of materials which we are going to modify. That's why our R&D efforts are focused on the creation of modifiers which can be used without change of a technological process. The first modifier, the first group of modifiers which was created is number of suspensions of single-wall carbon nanotubes in various solvents. Here you can see the technological process, general technological process of production of a suspension. Here we have to solve two tasks. First, we should deagglomerate, split bundles of nanotubes into individual tubes. And the second task is to stabilize the suspension. For this purpose, various surfactants are used. Finally, a number of suspensions in various solvents have been created. Some of them are presented on this slide. Here are main methods which are used in quality control of suspensions. Now, I'm proud to say that our suspensions are widely used in several applications, such as electrochemical power sources, paints and coatings, and others. But the concentration of carbon nanotubes in a suspension is limited. And there are many very promising applications which need much higher concentration. Three years ago, our scientists solved this challenge. Our scientists discovered that high wettability of if we have a matrix with high wettability to the carbon nanotubes and apply shear forces, we can just create modifiers in great number of matrices. And we've created families, several families, not products, but families of products called two-ball matrix, which are now widely used all over the world, but by a great number of companies. The next challenge. You know that the concentration of non-carbon impurities in two-ball is very, very low. But there are several, again, very promising applications with a huge potential market which needed much lower concentration. And last year, we solved this problem. We created a technology, scalable technology of purification of carbon nanotubes. Here you can see TEM images of two-ball before and after purification. The concentration of metal impurities in final product is much lower than 1.8%. My colleagues tomorrow will, today all the reports was about applications, were about applications of two-ball. And tomorrow my colleagues will tell you about many achievements of our R&D and product developers teams. I just want to tell you about few, in my opinion, not typical results. The first one. It's well known from the literature then, that when we use carbon fibers and carbon nanotubes together, we obtain a synergetic effect. This is the result obtained in our laboratory in the system containing epoxy resin, carbon fibers, and carbon nanotubes. As you can see from the slide, the flexural strength increases 3 times compared to the neat polymer. Another very impressive and promising application is use of two-ball to modified asphalt. These are results, laboratory results, very promising. But this spring, together with our industrial partner, we produced 1 kilometer of highway modified with two-ball. Another application, not usual use of two-ball. There is so-called reaction injection molding method, which is widely used to produce composites with thermoplastic polymers. And when you produce a part made of polyamide 6, the source polymer is so-called caprolactam, and the main problem here is very low viscosity of caprolactam. To solve this problem, usually different modifiers, different additives are used, but use of those additives increases viscosity but decreases the mechanical properties of the final polymer. If you use here ball just as an instrument which allows us to control viscosity, the problem disappears. You know that we produce tons of ball, and it's quite natural that we dream not to use it only as a modifier, but we'd be happy to produce material containing 50, 60, 90, or maybe 100% of ball. And this is the first material from this family, so-called ball paper. The paper is very strong, very highly conductive, and on this slide you can see several potential applications of this material. The most obvious and most promising one is the use of ball paper instead of heavy metal shields in data cables. One more challenge. When you deal with nanomaterials, problems of health, safety, and ecology should not be overlooked. And you can find a lot of papers where authors state that carbon nanotubes are very harmful. You can find the same number of papers where authors state that there is no harmful effect to living organism from carbon nanotubes. My recommendation: believe nobody. Believe only the results of those experiments which are performed with concrete nanomaterial. Here you can see just one example. The results of the study of toxic effects on algae. Both experiments were produced using the same OECD guideline. And you can see here that in the case of ball, there was no toxic effect. In the case of multi-wall carbon nanotubes, there was toxic effect. What's the explanation? According to opinion of Dietler Schuler, one of the leading specialists in the area of toxicology, the reason is very simple. Single-wall carbon nanotubes are much more flexible than multi-wall carbon nanotubes and carbon nanofibers, and that's why they do not harm the cells. So taking into account the above mentioned, we initiated a huge number of experiments which have been produced in various laboratories all over the world. By the way, so far no harmful effect has been obtained, but we continue this work. And as a result of these studies, we got the REACH certificate, and now we are on the last stage of the EPA permission. This allows us to produce or to sell tons of carbon nanotubes in the United States and Europe. And what do you think? What will be the next challenge? I'm convinced that the result of our combined efforts to create the market very soon will the demand will dramatically increase, and production facility of Graphitron 1.0 plus even Graphitron 50 will not satisfy this demand. What is the solution? Solution is very simple. It will be Graphitron 250. It will be the reactor which will produce more than 250 tons per year. The Graphitron 250 will be located in Luxembourg. We started last year the engineering process. We have relocated all the flowers from the red book, which grew on the Graphitron plant, and starting engineering. So thank you for the attention. By the way, Gregory promised that I will tell you about the price. The only thing which I can tell about the price is that it's quite obvious I think for everybody here and for me, that if the production volume grows, price drops down. But I cannot predict right now what will be the price tomorrow or the day after tomorrow or in 2 years. Sorry for that.
Of course you can't. Of course you can't. It's my job.
Okay.
For sure. Thank you, Alexander.